Welcome back. So as we do usually, I'm going to start out by starting the Jupyter Notebook. The way that I usually do that is by starting a terminal, and then let me change to, let me see what directories I have here. I think I want to change to Documents, and then GitHub, and then Intro Speech Understanding, and then, oops, that's not the right one. Let's see. I've got multiple copies of this. This must be it. All right. And then let's try starting a Jupyter Notebook. And this week will be lecture 4. This will be the last of our lectures about standard Python. And then next week we'll be talking about NumPy and Matplotlib. So 2 weeks ago, before Golden Week, we covered, so let's go back. 4 weeks ago, before Golden Week, I introduced you to GitHub and to checking in your homework assignments on GitHub so that I can grade them. And all of you have been doing that successfully. 3 weeks ago, I introduced you to the basic data types in Python, and those basic data types are strings and integers and floating point numbers. Also learned about if-then statements, if-then else statements, and we learned how to import modules, and we learned how to define functions. 2 weeks ago, before Golden Week, we learned about our first major kind of container object, and that was the list. A list is you use square brackets, the square bracket symbol to open it, and that allows you to create just a sequence of an arbitrary set of objects. Some of them might be strings, some of them might be numbers, some of them might be Boolean, some of them might even be other lists. We also learned about the tuple data type, which is like a list, but not changeable. Once you create a tuple, it cannot be changed. And we learned about list comprehension, which is a for loop embedded inside a list so that you can create a list implicitly by specifying a function that gets run every time as you work through the range. So far, those objects are very similar to the objects that you would find in C or C++. But today I want to talk about, well, we've already covered tuples. I want to talk about dictionaries. A dictionary is a kind of object that is hard to reach in C++. It doesn't exist at all in the C language, but it's extremely useful. You might reasonably argue that the dictionary is the main data type of Python. It's also the main data type of Perl and some other high-level programming languages. Essentially, a dictionary is like an array, except that the index is not an integer. The index into the dictionary can be any non-changeable data type. So you can use a string as an index into a dictionary. Um, that allows you to look up, for example, you could create a Japanese to English dictionary where the Japanese word is the index and the English word is the value, or vice versa. You can also use tuples as indexes into dictionaries, or integers or floating point numbers. So let's make sure that your version of the homework is up to date. Let's do git fetch release. So let me create a new shell where I can do that. And let's change into KCGI, intro speech understanding. And then let's do git fetch release. I think I should be up to date, but we can just check to make sure. Oh, it looks like there might be something else to include. So let's try merging it. Git merge release slash main. What else does it say? It says I have
现在就
to
可以
add
睡
a
觉呀！我操！对
是，
啊，我操！哦，哎呀，
卖没光，卖
would you
没
mind
光，没光。
here, let me mute you. Um, All right. So we're going to use git release main, and we will have a comment, the -m for the comment. So I'll just say I'm merging the release. And then we want to allow unrelated histories just to make sure that if if there's a history that's the same, if there's changes that are made on the GitHub site that are not made in my local version, then those can be combined. So I'm merging in lecture 3 grade.py and lecture 3 notebook, and there is a conflict in lecture 3 notebook. So we have to fix the conflicts and then commit the results. Um, I'm just going to commit it as is, fix them in the work tree, and then use git add rm files as appropriate. Okay, let's try that actually. That's interesting. Let me go, let me go up um, to lecture 3, where it said that I have the conflict. And then let's open the lecture 3 notebook. Oh, let's discard those and let's actually, um, hmm, let's just remove that for now since we're past lecture 3 already. I'm trying to figure out how to deal with this merged conflict, and one way to do it will be to simply remove that file. So let's go to lecture 3, and I'm just going to remove the lecture 3 notebook. We'll do git rm lecto3 notebook.ipynb, and then git commit fix something, and git push. That's just copying my version. All right, now let's go up to lecture 4. And now we should have our Jupyter notebook. All right, so now we've fetched the release and we've merged it into our copy. Now we can change directly to lecture 4 and start the Jupyter notebook. Let's work on the Python stuff. So today's lecture is about dictionaries. A dictionary is like a list, except that instead of being indexed by integers, you can use almost anything as the index. And the syntax uses braces instead of brackets. Braces are these curly things, right? So parentheses are a smooth curve, braces have these multiple curve, and a bracket is square like this. And so here's a dictionary. This is a dictionary where the key 0 is the index that returns the value. This is the number 0. And the key, some key, is the index that returns the value 35. Rather than indexes, dictionaries have keys and values. So if I create this, we can see that when I print out this dictionary, it has the number 0, index is the string. This is value number 0. And the string, some key, indexes the value 35. So if I print here the entry indexed, the entry whose key is some key is, and then I can print that value. And then let's also try the entry whose key is 0 is, and let's print the dictionary value for 0. And we can see that, in fact, the string some key returns the value 35. The string 0 returns the string, this is value number 0. So in this way, a dictionary can map anything to anything. You can almost map from any arbitrary kind of data to any other arbitrary kind of data. Just about the only things that you can't use as the key are lists and other dictionaries. So a tuple can be used as a key, but a list cannot. Dictionaries are useful because we can use methods to find interesting things about them. So the method .keys returns all of the keys for the dictionary. So we can go through and enumerate all of the keys in the dictionary. N will be the number and K will be the key. And we'll print out key number N is K, and it will give us those values. So we have key number 0 is the number 0. Key number 1 is the string, some key. We can also print out the values. The values are the things that are indexed by those integers. So the integer 0 indexes the string. This is value number 0. The string some key indexes the value 35. If you want to get the key and the value together as a single item, you can index items like this. And what this will return is a set of tuples. Here we have the tuple where the first entry in that tuple is the key, and the second entry in that tuple is the value. So in this case, we have the key is 0 and the value is, this is value number 0. The key is some key and the value is 35. In fact, let's print out, and its key is K0, and its value is, and then we'll print K1 because the tuple is a pair, right? The first entry, K0, is the index, and the second entry is the value. If we run this, then it will print item number 0 is the tuple 0, comma, string. This is value number 0. Its key is 0. Its value is the string. Item number 1 is the string some key followed by the integer 35. Its key is the string some key. Its value is 35. So dictionaries in this way can map from almost anything to almost anything else. Let me add another entry here. Let me say, hello there will be a tuple with two strings that will map to another tuple. Let me add that to the dictionary. And then let me add the printout here so we can see the entry whose key is hello there is, and then we'll print it. So you can use tuples as keys into the dictionary exactly the same way that you would use integers or strings, right? The tuple hello there is an index into the dictionary, and the string and the tuple this is a tuple is the value that's stored at that location. Let's print those out. Now the keys in this dictionary are 0, some key, and hello there. Now its values are this is value number 0, 35, and this is a tuple. And now this total set of items looks like this. We've added a third item that maps from a tuple to another tuple. Right? That's all useful because tuples are basically like lists, except that they're not writable. So a tuple is just like a list, except it's not writable. You can create it once, but you can't write to it once you've created it. So we can print out the list, we can print out the tuple, we can change the list, but we cannot change the tuple. You see, so we print out the list, we print out the tuple, we change the list, and that works just fine. But we change the tuple and we get an error. And the error comes because the tuple object can't be changed once you've created it. We can't go in and this line caused the error. We can't go in and change the value in a tuple. And that's the reason why it's possible to use a tuple as the key into a dictionary, because once you've created the tuple, it always stays the same. And so since it can't be changed once it's been created, it's possible to use it as an index into a dictionary. Right? The reason that tuples are unchangeable is so that they can be used as keys for dictionaries. So for example, suppose you want to store all of the people who have birthdays on January 10th, you could create a dictionary birthdays, but you can't actually create a list 110, January 10th, as the index to tell you that you want to list Fred and Anna as the people who have birthdays on that date. But you can use the tuple. The tuple 1, 10 can be used to mark that this is the date, January 10th. And the content is the list of people who have birthdays on January 10th. And that list is Fred and Anna. We can actually add somebody. Let's say birthdays 110, and that's the list Fred Anna. And let's concatenate to it one more person. Let's concatenate Joe. And then once we've added Joe to it, let's print it out again. And you can see that, oh, it actually added it letter by letter, didn't it? Um, let me put this into a list and see if that solves the problem. Let me add the list to Joe, and we will try adding that to the original list. There we go, Fred, Anna, and Joe. So we took the original list and we extended it by adding another list to it. And that gave us the new dictionaries. Other than that, tuples are just like lists. You can add them or multiply them just like lists. So we can add list one plus list three, and it gives us hello world ABC. We can add tuple one plus tuple three, and that gives us hello world ABC. We can take list three and multiply it by four, and that just duplicates it 4 times. We can take tuple three and multiply it by two, and that just duplicates it 2 times. So lists and tuples behave exactly the same way. The only difference is that you can't write to the elements of a tuple. All right. That's all of the new content for today. It's actually pretty simple in a way. We just want to find dictionaries. The homework this week will be a little bit more complicated. So let's print it out. The homework will just have one function, and that function will be next birthday. Excuse me, will be next birthday after a date. So the goal of next birthday will be to find the next birthday after a given date. So the date will be a tuple of 2 integers, specifying the month and the day, like January 10th, for example. The birthdays will be a dictionary mapping from tuples to lists of names. So birthdays 1, 10 is the list of all of the people whose birthdays are on January 10th. So our birthdays dictionary will be fairly small, but we can gradually build it up if we want to. And what it should return is the next day after the given date on which somebody has a birthday, and the list of the names of people who have birthdays on that date. So we could create a dictionary like this, where Anna and Bob have dictionaries on January 10th. St. Valentine has a birthday on February 14th. Mary has a birthday on March 3rd. And Seth and Fred have birthdays on September 19th. And then we can print out the birthdays dictionary, and then we can return the next birthday after June 6th, right? So the next birthday after June 6th should be Seth and Fred on September 19th. This doesn't work yet, right? The birthday and list of names just returns nothing. It's returning an empty list. But what we want to return is a list of names and a birthday. If I give a date in October, then it should go back around to the beginning of the dictionary. So let's open this file. Let's see if I can find it. Let's go up to lecture 4, and let's open homework4.py. All right, so we want to find the next birthday after the given date. So we can start out on January 1st, I guess. What we want to do is we want to search through the birthdays to find the next birthday after the given date. So I'm going to go ahead and do this kind of the slow way. I'm going to say that month is equal to date 0, and day is equal to date 1, right? So I'll take the date, which specifies the month and the day. I'm going to get rid of this because that doesn't seem like a reasonable way to go. So we'll find the month and we'll find the date. And then we want to kind of go through all of the keys in birthdays, right? And we want to sort them according to their month and their date. So let's say sorted keys is equal to sorted birthdays.keys, and this will return a list of the keys and the birthdays that's sorted in order, increasing order of date, increasing order of month and day. And then we will search to find one of those sorted keys whose month is greater than or equal to month. So let's start out with past month is equal to, um, let's see, let's set I is equal to 0. And then while sorted keys of I of 0 is greater than the month and I is less than sorted keys, less than the length of sorted keys, and we'll increment I. And then now that we've found a month which is greater than or equal to we found a sorted key that has a date that comes before the month. Let's see, we want to find the next day after a given date on which somebody has a birthday. Oh, so we should probably count backwards, shouldn't we? Oh, we want to find the next date after. So we want to say, while the sorted key is, while the month of the sorted key is less than the month of the date that we're looking for, we continue to increment. And then we want to find the next day after. So we want to say, well, sorted keys I of 1 is less than the day. And as long as I is less than the length of the sorted keys, then I is plus equal to 1. And by now that we've found a month which is less than or equal to this, now that we found a sorted keys 0, which is greater than or equal to the month, and a sorted keys 1, which is greater than or equal to the day, now we found the correct, now we should have an I set which is valid unless this condition was met. If I is greater than or equal to the length of the sorted keys, then we have to go back and start over again at the beginning. So we can take if I is greater than or equal to the length of the sorted keys, then in that case, what we should return is the very first birthday and the dictionary content. There, the nice thing about this homework, by the way, is that there are many, many ways to solve it. I've seen students come up with many different solutions, but here's a possibility. Now we've found either we've gone to the end of the list, meaning we've burned up all of the keys, in which case, if we've burned up all of the keys, then we should return the very first birthday in the list and the associated list of people. Otherwise, what we should return is the sorted keys of I and the births are listed under that sorted keys. All right, and we don't need this anymore because we've satisfied. So we have two conditions. Either we found an I which is satisfies the condition that the month is greater than or equal to our desired month, and the day is greater than or equal to our desired day. Actually, yeah, we don't care about this unless we're in the same month, right? So let's say if sorted keys I0 is equal to the month, then we care about this. And if not, then, well, that's all. If the month of the sorted key is equal to the month that we're looking for, then we go until we get past the desired day. Otherwise, we've already found the first I that matches. So this first condition checks to make sure that the key that we've retrieved from the birthday is greater than or equal to the desired month. The second key condition checks to say if we're in the same month, then make sure that we're past the same day. And then finally, we check to see if we've actually run out of the end of the dictionary. Then we just return the very first birthday. We just cycle back around. All right, this is fairly complicated, and you can work through the logic of this one because this is one where there are many, many different ways in which you can solve this homework. Here's one particular solution that you can use, but you can try to work through the logic. The idea is that we want to return the next day after the given date on which somebody has a birthday. So let's test and see if this works here. We want to reload the next birthday after June 6th is September 19th, and the list of people with birthdays on that date is Seth and Fred. If we enter, let's see, how about if we enter July 14th, we'll find the next birthday after um, date is equal to 7/14, and we'll put date here. The next birthday after comma date, comma is, and then the birthday. So the next birthday after July 14th is September 19th, and the people with birthdays on that date are Seth and Fred. Let's take a much earlier birthday. Let's take, for example, February 1st. The next birthday after February 1st is February 14th. The people with birthdays on that date are Valentine. Let's take an even earlier birthday. Let's take January 1st. The next birthday after January 1st is January 10th. The people with birthdays on that date are Anna and Bob. Let's take March 1st. The next birthday after March 1st is March 3rd. The people with birthdays on that date are Mary. And then let's do something difficult. Let's take November 1st. Well, I've got a mistake in my code. List index out of range. All right, my code didn't go back around the way it was supposed to. So what did I do here? I got the month, which was date 0, and I said, well, sorted keys is less than the month, and let's say while I is less than the length of the sorted keys, and sorted keys less than month. I think that Python does an ordering like this, where it checks this condition first and only goes on to the second condition if the first condition is satisfied. So let's try that again here. So this will only increment if I is less than the length of the sorted keys. Let's check to see if that works. Nope, that's still causing a problem. Let's try maybe while I is less than the length of sorted keys, if, hmm, maybe we can try minimum of I or length of sorted keys -1. And then maybe I can try the same here. I'm not sure actually if this is the place where I'm having trouble with my code or not. It seems like that might not be the place where I'm having trouble with the code. See if it tells us. It says that the list index is out of range when I'm running this. Error retrieving source code with stack data. Why is it having an error retrieving the source code? Normally it would give me an error here telling me exactly which line it's had trouble with. Oh, it does say line 21. Let's see what line 21 is. If sorted keys I0 is equal to month. Oh, that's where the problem is. That's why. So we don't need this, and we don't need this because those both come after the condition that specifies that I is length in sorted keys. All I needed was something here. If I is less than the length of sorted keys and sorted keys is equal to the month, then try those things. So I just have this check on each case to make sure that I is actually within range. All right, let's make sure, let's see if that works. Ah, that solves the problem. So the next birthday after November 1st is January 10th. So this is the desired behavior, right? We want it to wrap around. The way I made it wrap around was check to make sure that it is still less than the length of sorted keys. And then if so, then I check to see if the sorted keys is less than the month. And if so, I increment I. Here, if I is less than the length of sorted keys and the sorted keys are equal to the month, then I check while I is less than the length of sorted keys and sorted keys is less than the day, then I increment I. Actually, I want to put all of these things together, don't I? I want to say, while I is less than the length of the sorted keys and sorted keys of I is equal to the month and sorted keys of I is less than the day, then I want to increment I. Um, Otherwise, if the key is not in the same month, then by that time I don't care, so I don't need to increment I anymore. Let's make sure that this still works. All right, that looks like that works. Let's check to see if the grading code works. And the grading code works, and it gave me 100% for this assignment. Let's just test this. Let's try, for example, February 1st. It found February 14th. How about if we try February 21st? That should give us March 3rd as the next date. Yep, the next birthday after February 21st is March 3rd. So it seems to be giving us the correct answers all the way through. All right, that's the complete homework for this week. Really, I mean, the only way in which we really used the dictionary idea was we took that tuple, the key, which was the date, and we used that as the index into the birthdays dictionary in order to return the list of people who had that birthday, right? Other than that, I mostly just took the keys from the birthday and sorted them and returned that as a list of tuples. And that list of tuples gave me the list of birthdays in order. Let's go ahead and open GitHub Desktop and check it in. I think that's all that we have to do for this week. Let's see if I can commit this. Homework 4. And let's try pushing it. That seems like that's worked. Let's just check to make sure. Let me go to my GitHub page. Let me change from my teacher account to my student account. And on my student account, I should be able to look at lecture 4 and look at the homework and see the code that I've just written. There it is. There's the code that I've just written. And so I can copy this URL and go to our Canvas page for this course. All right, let's open the course and then go to the homework. And then on this homework, we have please enter the URL of your copy of Homework 4.py. So you should be able to enter the URL of your copy of Homework 4, and then once you've done that, I will be able to grade it and give you your score. Um, that's all for this week. So let's go to take attendance. And let me stop the recording.